All right, so today we're going to be looking at our object on a slope once again, but this time we're going to be applying a force into the box. Essentially, I'm trying to push this object up my slope, and it's a big enough object that I can't just push up. Essentially, I can only apply a horizontal force into it. Um, and I need to know how much force I need to push into it before it starts moving upward. Intuition, kind of common sense should tell us that this box is trying to slide downhill. Like if this is a frictionless slope, or if it's like a slope with a bunch of rollers on it, if I wasn't here pushing on it, this box would just slide downhill. So the first thing I need to figure out is what force is being applied in kind of that downward direction. So this is where we're going to go back and we need to figure out first what's our force of gravity, and then we can figure out things like, that's actually pretty good. What's my force of gravity in the y direction, and then force of gravity in the x direction. All right. So first thing we have to do is we have to figure this part out. So looking at just that f of g, let's see how well I can recreate this. I don't think very well, but that's all right. Maybe that's not horrible. All right. First thing to remember, this f of g right here, we can even calculate this out real quick. So f of g is equal to, let's say mass 30 kilograms times negative 9.81 meters per second squared. Can't do that one off the top of my head. Ignore that number. 30 times 9.81 equals 294.3. All right. All right, so that's my f of g. That's this number right here. And we have f g of y, f g of x. All right, so I know this number. And remember, all of that geometry stuff we kind of just glossed over told us that this angle right here is equal to this angle here, so 25 degrees. All right, so using that, I can figure out what the side adjacent to the angle is, so that'd be my y. F g of y is equal to 294.3. And this part's just kind of a review of yesterday, times cosine the adjacent one, cosine of 35. All right. So FG of y, I'm going to go to my smartphone-ish calculator on my phone. That's right, smartphone-ish calculator on my phone. All right. 294.3 times cosine of 35. For that answer, I got 241. I'm going to leave it at 241. Ignore that word. All right, 241 newtons. All right. The reason why I found this is chances are they're going to ask me to find, the normal force as well. And then let's see, FG of x. So in this case, FG of x is going to be 200. That should have been a negative. That should be a negative as well. 294.3 times the sine of 35. Because really, this is the one that I'm really going to be concerned with the way I worded the question. So in this case, finding that value, once again, go back to the calculator. Sine of 35. This one I got 168.8. Newtons. All right. All right, so I've got this whole triangle figured out. So if I come back to the box here, I'll even kind of redraw my box. Let's pretend it's at that angle, so 30 kilograms. I know that if I'm looking here, there's a force being applied this way by gravity. That's my FG of x of 168.8 newtons. Okay. If this slope is frictionless, I am applying a force in this direction. All right, so the minimum amount of force I need to push this box kind of up that slope, if I'm pushing in this direction though, since we kind of alter the x and y axes there, that's not really going to work for us. So essentially, I need to look at this line here, break it up into x and y components as well. So, and if this is the minimum I have to reach in kind of this new x direction, that's also the minimum I'd have to be in the other direction. So I kind of need a new triangle where we're looking at if I know that this is 168.8 newtons, this angle will be the same as this angle here. So this is also 25 degrees. All right, that's going to help us. This would be my force applied. And then we would also have a force that ends up going up, or I guess kind of into it, depending on how you want to look at it. Really, though, I don't really care about, in this question, out of my horizontal force, how much of it's being used to actually raise the box. That would be like a question for another time. Right now, I just need this, the force applied. If, if this downward force, I can even put it right here. All right, let's slow down. I need to know how much force do I need to apply horizontally to get essentially a hypotenuse of 168.8 newtons kind of going in that direction. That's what's being represented here. I'm pushing horizontally, but because of that slope, the slope will kind of absorb some of it and kind of direct it in the upward direction. The rest of it will be used to kind of push that box kind of horizontally. And so I'm worried about this. So I'm going to go back to my trig. So in this case, I know the hypotenuse, I know the angle, I need to know the side adjacent to my angle. So I'm going back to cosine. So in this case, I'm still just going to do, so really what we're finding is sine of 25 is equal to adjacent, or my force applied, over the hypotenuse, 168.8. All right. Algebra to get that by itself. Really, I'm just going to take 168.8 times the sine of 25. And I get 71.3. All right. So if I apply 71.3, oh, you know what? I did that wrong. Okay. Ignore that part. Teachers make mistakes. All right. Really what I'm looking at is that's my applied force. Really what that's going to turn into is a force that way and a force that way. I found the hypotenuse, okay? That's 25 degrees. That's a right angle. I really needed. That's what I'm looking for. That's what I did wrong. All right. So ignore this stuff down here. I'm going to scribble a little bit more. And I need to hurry up here. All right. So in this case, we're still using trig. I'm still looking for that sine because we know that this is 168.8 newtons. All right. Now that I'm using the right triangle. So in this case, I'm looking for the hypotenuse. So we know that I'm still using cosine because I know the side adjacent to the angle there. So cosine of 25 is equal to adjacent over the hypotenuse, which is what we're looking for. All right. Algebra will tell me that if I do multiply both sides by force applied and divide by both sides by cosine of 25. I know I'm starting to jumble up here. That's the math I need to do. All right. So let's go 168.8 divided by cosine of 25. This time I'm going to get the right answer. So I need to apply 180, we'll say 6 point, let's say 25. All right, that's what I need to exert. Final answer right there. All right. I need to push with 186.25 newtons horizontally on the box in order just to keep it to stop moving. Because essentially at that point, my f of x, or my f applied in the x direction, we said this was the x direction, would equal the amount, the fg of x, the amount kind of pushing down on it. If I apply more than this much horizontally, I'll now have a net force that's kind of up in this direction. Because I can't move into the slope, that'll be canceled out by a new normal force, which we'll talk about in class a little bit. That will become important when we start looking at things like friction, stuff like that. But other than that, being able to apply our same triangle whatnots now to our applied force is just going to let us do a little bit more math, do a little bit more kind of mechanical engineering, and kind of go from there. Sorry about that mistake I made. I know it wasted a little bit of time, but good luck with the practice problems.